Okay, I think we're in a good time to go ahead and get started. Welcome everybody. My name is Pablo Vial. I'm the marketing director here at Renon Power, and I'm joined with my co-host Russell Willems. Russell is our director of customer empowerment, and so we're looking forward to showing one of our latest products that's coming here to the States in a month or so. So, looking forward to giving you guys a top level um, perspective and view of this product. So we're Red and Power. Today we're going to be covering battery integrated DC fast charging solutions, our all-in-one specifically. So who we are, we're headquartered in McKinney, Texas, founded by Paul Buckwalter, our veteran CEO and co-founder. Um, and we have several veterans on staff as well. So we're really excited to onboard veterans as well as people from the industry and those that are looking to develop their careers in battery energy storage. So we do have locations in the United States as well as Japan, and we have offices in the Netherlands as well, in addition to our factory in China. Core businesses include residential batteries, commercial and industrial BESS, battery buffered fast charging solutions, which we'll be covering today, and portable BESS. So for those of you that have joined us in the past, maybe you're familiar with our residential lineup. We made a big push with commercial and industrial products last year, and those are rolling out and being deployed all around North America currently, which is exciting. Globally, we do have a very large presence on the commercial and industrial size solutions, as well as residential. So, as I mentioned before, we have our headquarters here in the United States in McKinney, Texas, where we're actually in the process of building our 3 gigawatt hour capable facility. We also have offices in the Netherlands that cover EU, we have projects in Africa that they cover as well. And then Japan. Japan has a large CNI presence from our product lineup over the last 12 years. So I'll give you a rough timeline of our history. Uh, we were established in 2014, focused primarily on BMS. In 2017, we moved into home energy storage solutions that were targeted for the European market and Japanese markets as well. And in 2019, we launched our commercial and industrial solutions. So our goal is to have everything necessary from the BMS, the EMS, the BESS, and so on. So everything you need in one solution, and then optional inverters as you prefer. In 2022, we moved on to a second generation of home energy storage solutions. 2023, we built our new R&D center, and in 24, we struck a strategic partnership with Solar here for the North American industry or market. And last year we did the same with Fronius, Solus, and a handful of other inverter manufacturers, in addition to securing our new facility, which you can see in the photo here in McKinney, Texas, which is located about 30 minutes north of Dallas, about 30 minutes from DFW Airport. And this plant is really exciting for us. It's a huge move forward for the progress of our organization. But we'll have two lines in place. We'll have a residential line. We'll assemble and manufacture everything except for the cell, and same thing for commercial industrial. These are heavily automated lines, and we're really looking forward to sharing more on those here in the next couple weeks as we've made some substantial progress for those of you that have followed. So looking forward to that. We'll also have an R&D center here in the United States where we'll be developing our products to reach fiat compliance, BABA compliance with all the domestic requirement or domestic content requirements and leadership requirements as well here in North America. So again, our North American organization is a separate organization from our global organization. North America is owned and operated by Americans and by uh, Paul Buckwalter, our veteran owner and CEO. So, and then we currently import product from our partner factory in China, um, with the plans of building our own product here in the States here in a few months. So, I guess we'll jump on to our leadership team. This is Paul Buckwalter. I've mentioned him a couple times. Jane Hugh is our general manager and co-founder. Joshua Brown is our residential energy storage solutions director. Jose Illich is our engineering manager, myself, director of marketing, and Russell Williams, who you see here on the webinar as well. He's our director of customer empowerment. And I do encourage you all to go ahead and leave questions and comments in the Q&A section here, and we'll answer those as we move along. So I'll go ahead and hand over the presentation to Russell at this point, and we'll get a little bit more technical. Just a quick background on myself before we do that is I do have experience in the EV charging space. I've worked on both level 2 and level 3 DC fast chargers pretty recently, actually, right before I joined Renon. So I'll be jumping in to answer questions as well as supplementing along with this presentation. So otherwise, thank you so much. And go ahead, Russell. Thanks.
Awesome. Thank you, Pablo. Very much appreciate the intro. It's always nice to do a quick overview of the company. For those of you that have attended a few of these, that is something that's fairly consistent, so we try and move through that fairly quickly here. Pretty excited to share the EV fast charger. The EStand is what we're referring to it as. It's something that has been on our to deliver list for quite some time. As Pablo briefly mentioned, we are expecting it to have full UL certifications by the end of April. So that's just a month or so away here. Quite exciting. And with that, there's a few things that make, excuse me, sorry, that make us stand out as a company and in our approach to EV charging as well. So we are a very technology focused organization. So in the battery space, there's a lot of different white labelers, OEMs, cell manufacturers, a lot of different parts and pieces that come together to create the products that you see in the market. And one thing that sets Renon apart is that we have been developing our own BMS and EMS technology within the company, have several patents around it, and have been doing so for the last 12 years, almost at this point, which is pretty exciting. We really always have a major focus on safety and thermal management. That's a major aspect. That is some of the early concerns of LFP that or of lithium batteries in general. Lithium iron phosphate, which is what we use tier one cells, is significantly more sturdy, tested, proven, and all supported by very smart thermal management systems as well as fire suppression technology as well. Um, we also have our EMS integrations that are open to connecting with external sources, as well as really focused integration with different PCSs. So, as you saw on a few of those previous slides, we have partnerships with Solarc, Solus, Fronius, and then on the CNI side, some larger inverters. Cell is one that we're using in all of our CNI products these days. So, with that, let's start taking a look at what the EV space looks like. So there's a couple of things that make EV charging a little bit of a challenge, more of a challenge than people expect. A lot of the time, you think that you can just kind of on site drop a pollard, throw a few plugs on it, and then you're set to do some EV fast charging. A good example of this, I think, is like some Ford dealerships that right when they came out with that first Ford Lightning, all of a sudden with these few, there's only two or three chargers on site, so you wouldn't expect that big of an impact. But all of a sudden, these dealerships are seeing their demand charges almost triple in the short period of time. And the reason for that is that when you plug in a fast charger, it's instantaneously drawing a ton of power from the grid all at once. It says, give me as much as I can in inflow. And when you have two or three of those running out together, all of a sudden, your site that normally has a nominal charge from the grid, it's like supporting the light, supporting the power, maybe 30 to 50 kilowatts anytime instantaneous draw, all of a sudden can shoot up to 80, 100 kilowatts when you have a bunch of three EV, even as few as three EV chargers plugged in at once. So there's a lot of factors that impacts. So there's large grid connections in order to be able to even connect that much power to it. And in some cases, the grid infrastructure isn't even capable of supporting it. There's some places that might need new transformers or require grid upgrades or running a larger power line out to your center. If you're especially trying to charge a full EV fleet, the existing infrastructure was not intended to support that much energy being moved. As I mentioned, the demand charges really, really get out of hand very quickly. And then there's just sometimes not enough power on site. There's been some cases where people will put in a pollard, they try and go to charge, and when they charge, they'll see dimming in the rest of their facility. So it depends on how it's wired into the system and how all those other things are connected. Um, it's good to start with an understanding of what some of these challenges are, because when it comes to using EV fast chargers, One way to mitigate almost all of these challenges is the integration of energy storage. So let's look at how we seek to impact the EV infrastructure need by adding energy storage. So um, when you have a energy storage system, battery energy storage system that can slowly charge from the grid. So let's say your standard consumption from the grid is 30 kilowatts. You can only lift it up to 35 kilowatts, and then you have just a consistent 5 kilowatt flow into that battery. For example, what we're looking at here is our MPACs that we'll talk more about today, is a 250 or 261 kilowatt hour system. Uh, so the battery can charge slowly and then very quickly discharge from the to the DC fast charging system. So it can slowly charge over a course of 5 to 10 minutes, or sorry, 5 to 10 hours, and then discharge all at once to support the grid. So what that means is that you don't require major grid upgrades, so you can do a faster deployment. You don't have to have the grid come in and do full rebuilds or infrastructure changes in order to be able to install a DC fast charging system. The cost for the charge point operators is significantly reduced because you don't necessarily have to take in major investment from grid infrastructure or grid changes. So that's a pretty significant change there. And then finally, it gives you a lot more flexibility around power management. So, for example, if you know people are going to be charging their cars while they're there for work from 10 a.m. to 5 p.m., and there's some large energy costs in that window as well. If you're doing manufacturing, for example, you can then choose to charge these batteries at night when you know your consumption demand is lower. So, say during the day, you're usually consuming 50 kilowatts. At night, you're typically consuming 15 kilowatts. Overnight, you can charge the batteries at, let's say, 35 kilowatts, and then you're kind of maintaining that standard flat line. But then by the time you get to the morning, you have a couple hundred kilowatt hours of energy prepared to be disposed or prepared to be discharged in a really rapid rate in order to support the EV charging. So all of those factors come together to focus on the product that we're bringing to market here, the EStand. The real goal of the EStand is to serve as a battery buffered DC fast charger system. It's an all-in-one, fully integrated system that gives you both the batteries to charge slowly or quickly and solve a lot of those problems that we talked about, as well as the full charge point connection, the actual charger that will plug into your battery. We have a strategic partnership with an industry leader that has a global footprint in terms of their chargers, Winline. They're who actually produce the plugs and control systems. So it will be a payment receiving interface. Customers can go through, plug in, and be able to pay directly. This has been they have already distributed their DC fast chargers globally. So it's a very proven product that we're excited to be able to have a direct partnership and to be able to integrate directly so we have some seamless control systems when utilizing their system. As you can see here, this is an example in which we have two of our MPACs. So each one on each side is a MPAC 261. So there's a total of 522 kilowatts in that system. Yeah, 522 kilowatt hours in that system. It is capable of being AC or DC coupled to the fast charger, or AC coupled to the grid infrastructure. If needed, we can also add MPPT cabinets onto the side of the batteries so you can directly charge the batteries from solar and then use that energy to charge the batteries. So if you needed to deploy these in a completely off-grid circumstance, you would be able to, which is a very interesting implication and use case there. Let's look a little bit more about some of the benefits that a DC fast charger can provide, that this system as a whole can provide. So it's stable and reliable performance in that if the grid goes down, you still have the ability to charge these batteries. The thermal management is the same thermal management that we have in all of our battery systems. It's very reliable and it's very safe. We have the cell temperature monitoring, cell voltage monitoring at every step of the way, as well as the fire suppression monitoring systems, internal emergency stops, as well as a blast lid for if there was, for whatever reason, to any pressure to build up, that's the direction the explosion would go first. Not that that's something, or that the pressure would relieve first. Not that that's something that we've ever seen happen or ever expect to happen, but it's just always good to have the additional safety precautions. Um, it really enables an eco-friendly approach to commerce, to commuting. As they've seen more and more EV cars become popular, the need for EV integration becomes more and more essential. And by having DC buffers, the battery buffers for DC fast charging, it enables you to lower the impact on the grid without really having to change infrastructure and to smooth out the entire energy consumption profile as we're getting this more and more energy demanding market as all of these things are happening. It's compatible, as I mentioned, with solar directly. You can also tie in wind or any other CCS1 charging interfaces. It's really versatile integration so that we can make it functional for the long term when it comes to the development of new EV protocols. It's a very compact design. We really have focused on making sure that these two can go side by side. The wiring runs directly into one another and makes it very easy to have a smooth, compact aesthetic for consumer experience while also delivering high amounts of power in order to leverage full DC fast charging capability. Um, we have a smart EMS system. Our EMS can tie into external APIs. It can pay attention to external energy like rates if we need to. That can all feed into choosing how to charge these batteries, how to combo charging of the batteries with discharge to the EV charging fleet or individual cars. It'll pay attention to typical charge patterns and adjust accordingly in order to optimize always having as much charge as possible at the lowest rate possible or lowest charge rate possible to minimize your demand charges. All of this is to support that cost-effective operation. So there's a couple different approaches that we can take in terms of topology for integrating this battery and EStand system. The standard approach is going to be our DC coupled system, which means that each of those batteries on the side has their own PCS in it. Those PCSs allow the battery to be AC coupled to the grid. So the grid can flow directly into the batteries, as we've been talking about. The battery can slowly charge and slowly provide additional storage. Um, as it's charging, we can then use the batteries to direct DC charge via DC directly to those chargers. And as a result of that, we're able to get slightly higher power output because you can discharge from the cells at the same time that we're pulling from the grid while keeping your total demand charges lower. So if you're just pulling from the grid and you're trying to pull a full 400 kilowatts, you're going to get a 400 kilowatt demand charge, which is astronomical at a rate of sometimes $7, $25 a kilowatt for demand charges. So being able to pull from the batteries, which can, as 0.5 C cells, when you have a total of 520 kilowatts or kilowatt hours, that's about 261 kilowatts of power that can be instantaneously discharged from the DC cells. When you pair that with the inverter, the Cell 135 inverter, that allows you to get additional power from the grid at a lower consumption rate while maximizing the total power to the DC fast chargers. So it really enables a lot of high power flow to make sure that these batteries are charging as quickly as possible. The other configuration is to use these in a AC coupled system. So an AC coupled system then runs batteries together. So this is a little bit different configuration. This is an example where rather than having the two batteries supporting a single a single DC fast charger, we have four of the M packs, all of them AC coupled to the grid setup, and then that tied to a grid through some switching as needed, flowing through the 480Y configuration, potentially connecting to a transformer, and then going through and supporting a AC coupled fast charger. So there's a lot of different chargers on the market, and this is the configuration you would use in a lot of the cases when trying to integrate with some third-party DC charger. So that's another advantage of these batteries, and we'll talk about that a little bit more here. Pablo, you have something to add here?
No, I was just going to say, like, that's a completely different solution that is available today, where you can bring your own charging dispenser or pylon, I guess. So if you have a solution that you prefer over this one here that you can see in the center, but you want to add battery buffering, that's something that we can currently offer depending on obviously certain charger capabilities. I know that if some of them have power modules built in, it does just extend the capacity of the energy rather than the power. But yeah, if there's a charger that you want to bring to the table and say, hey, let's add batteries to it, definitely reach out to us and we'll have one of our engineers help you design that system.
Yeah, exactly right. And this is that alternative use case, which gives you a lot more flexibility. So it doesn't require um, using our integrated system. I think there's a lot of advantage to using our integrated system. It's a pretty tried and true user interface. It's been implemented globally to have end consumers go through and actually walk up and charge their cars. Um, so there's a lot of advantage to having that kind of closed loop system. You get this really beautiful display, this really beautiful configuration of batteries and integrated charger. It's really aesthetic and it is a good form factor and very compact. However, there's certainly advantage to having custom use cases. There's a lot of places that might have existing DC fast chargers and they're tired of their demand charges and they want to just add batteries as an auxiliary addition after the fact, and that's exactly what this configuration would support. We can talk about that more if there's any specific questions on it. Now let's look a little bit at what the EStand's specs look like. And there's a couple different configurations depending on how many batteries you have. You can see here that there is the essentially one, two, three, or four different levels of storage, of power, of output power as well. And that is a result of how many MPAC 261s you have as a part of the system. So a single one is that 261. And in all cases, they will support the max power output from a plug of 400 kilowatts. So that enables all of these batteries to work together in order to produce that higher level of power output. So in a circumstance where you have just the two of them, one on each side, you can still hit that 400 kilowatts of power output from the batteries to support the charging. It will also be leveraging the grid, whereas if you have four of them, you can hit that 400 kilowatts of power without even having to pull from the grid. Pablo?
Yeah, I do want to take this moment to point out that on our marketing graphic, it says megawatt of megawatt plus. So that was a mistake. So apologies there. But you can see here the specs show that the dispensers themselves can output 400 kilowatts when there's a single car chart or car plugged in. But the battery, of course, has its own specs as well, which we can dig deeper into here in a moment.
Yeah, which we certainly will. And to clarify, the target was megawatt hour plus of storage with those chargers. So we certainly can have over a megawatt of storage. That's what four of these E-cube configurations would be. And that allows you to have potentially four of them with two plugs, allows you a lot of power output and allows both plugs to discharge at 400 kilowatts in order to support two cars. They would hit more than full charge very quickly there. And we could still go through four, five, six cars getting charged up very, very quickly when you have that level of storage in combination with connection to the grid or in combination with kind of slow charge from solar as needed. Um, the battery is really optimized for about 90% depth of discharge, service cycle of over 8,000 cycles, which is very, very good. And that's at full depth of discharge. So you can cycle them more when it's the shorter ranges of charge, which is likely, more than likely, the use case here, where you'll see them kind of deplete a little bit more slowly. You're only using maybe the middle 30 to 60% of the range when you just have one or two people kind of trickling through to charging them, versus doing a singular full charge up and down every time, like you do in some energy arbitrage applications or some different use cases. Let's look at some of the wiring configurations here of different ways that this can be integrated. So most simple board is just kind of direct grid tie-in. You connect the grid to the uh, PCS on each of the two MPACs. So each MPAC has that SYNXL 135 three-phase Y configuration that can run into it, which makes it very easy to hook up any 480 system, any 480 power setup into it. You can also potentially, if you're stepping down from medium voltage in the grid, or if you're into a weight or from some other energy configuration, utilizing a transformer, and you can use that transformer. We then can use just the batteries. The batteries can work together. They'll flow into an AC combiner, so you have unified power output, and that will support that DC fast charger. It can be ours, it can be a third party. So there's a lot of different flexibility. If you want to essentially deploy just those fast chargers standalone, you can put those out in a parking garage and have the whole battery bank be somewhere nearby rather than having to be directly behind every single parking spot. You can still utilize an AC combiner when connecting directly to the high voltage grid in order to just bring down high grid, run it through a transformer to bring it to 480. bring that in an AC combiner that would then distribute and charge a wide number uh, of the EStand modules. So there's kind of the standalone easy integrations for already in commercial energy levels. There's separating them from the charger, and then there's tagging into potentially new infrastructure. Say this is like a highway site that where you're trying to add a bunch of EV fast charging. Um, that can be done with like a step down transformer from that medium voltage from the grid that can then be distributed to power and support and charge all of these different batteries at different rates as needed. So definitely a lot of advantage, some different parallel mixed layouts that you can do here. It's important to talk about the EMS as well, what the energy control system is behind all of these. It is the similar EMS cloud that we have in all of our battery systems. It's fully integrated and supported by us. This is something we have patents on in terms of the energy management systems. It works at both the individual cabinet level as well as array and stack up level. So when you have multiple E-stands distributed across a segment, there is the flexibility to have the AC combiner and that control system and the EMS and the AC combiner actually flow charge from one set of batteries to another. So say you have two or three of these E-stands distributed in a parking spot. One just happens to be the easy pull straight in parking spot that is getting a lot more consumption. Instead of just having to pull from the grid to power that, our EMS system can communicate across the batteries and actually send power from one battery if the WAP allows for it, which we tend to pay attention to. And when we give in the configuration and we're doing single line reviews, we can confirm whether or not that setup would enable it. As long as there's an AC combiner, essentially, we should be able to do that no problem. And then it can hand energy from a potentially fully charged, lower used E-stand and then pass it off to a highly used E-stand in order to maintain charge rates while minimizing and keeping you from having to pull and get more spiked in demand charge. So it's really cool to see that level of flexibility. We've done a lot of part of the reason this product has taken a while to get to market is we've done some very, very rigorous integration and testing with our EV charger partner. So with Winline, who actually produce the DC charging ports and connections and interface, we've done some really sophisticated integrations to make sure that we have full communications with them, as well as watt metering, measurement, all the liquid cooling systems, the fire suppression. All of that gets integrated and computed in our cloud and in that integration platform. So let's look a little bit more at the battery that's supporting it all. So that is going to be the MPAC 233, sorry, MPAC 261. Oh, I will pause here actually for a minute, since it does look like we have some questions coming in here. Let's take a look at those real quick. All right. How many chargers per AC combiner? I believe three, three or four. We're still waiting on the final numbers there. Well, we're going to the EV Charger Conference next week in Vegas, and we're waiting on some finalized system answers, like system parameter answers that we'll have better for there. I believe per AC combiner, it would be up to five. It's usually up to five batteries. We might be extending it up to six batteries in order to support three full charger systems. So considering a charger system being two battery pairs in an E-stand. AC coupling is different than AC coupling with a different charging system. Yes. So that's something that we kind of briefly touched on when we're looking at the AC coupling layout. We are certainly capable of connecting with a different charge system. We have our Modbus protocols that we can hand off to if there's a third-party EMS control systems. Um, we're working with a couple different integration partners there because there's some companies that specialize in being kind of the communication or the translators between battery systems and charger systems, or other home EMS systems, maybe be generators, solar, wind, whatever other energy production or energy control systems. So we're doing full integration on that side of things. And it allows us to be flexible with any chargers on the market. So that's why we are capable of AC coupling with those different systems. Um, the smart matrix is not something that we have fully integrated into, yeah, the this charging system, but it is certainly still capable of being connected to our charge system and being connected to third-party chargers. That's part of that AC coupling is that the smart matrix is capable as well. And I think Pablo would
I
answer.
think the limitation with the smart matrix would simply be that they're super large and heavy. So if it goes like in a city, then that would be challenging due to the crane required to move the smart matrix. But if it's out in the middle of nowhere, then yeah, it's capable of doing um, most of the same functionality as the Impact 261.
Yeah, certainly. And I think that's an important thing to call out. The voltage standards of that system are a little bit higher. From everything I've seen, is the Smart Matrix would be AC integrated with this charge system or with an alternative charge system. But that's again still something that we can refine as there's use cases or as there's demand for it. If you have situations where you would prefer to use a Smart Matrix and use 1.67 megawatts, so over 1,000 kilowatts of energy, kilowatt hours of storage, that really gives you a lot of flexibility when it comes to trickle charging your batteries and fast charging to support the load, support the charging fleet. That's certainly something that we're capable of doing. And then last question that we currently have here is what is the EV charge power? And if we, I guess it's a few slides back, but 400 kilowatts is the charge power from the system. And that is per port we're capable of supporting. That is using, if you have two battery systems, you can and the battery systems have the power to fully discharge from DC. We can pull from the DC as well as the AC conversion in order to support that 400 kilowatts of power. So pretty high charge rate. A lot of cars are like barely on the brink of even being able to fully receive 400 kilowatts. So very high standard, and we're trying to make sure our products are future proofed in that they're capable of supporting really higher demand charge rates when cars start to be able to accept them on a more regular basis for consumers. That was a good line of questions. I'm happy to answer more. I really appreciate them. Al, please drop in any others. If anybody else has additional questions, I'm happy to answer them as we go here. Um, I'm not seeing any others come through at the moment, so I will keep going and talk a little bit more about the 261, which I think is something that a lot of you may be familiar with, as it is kind of a bread and butter product for us. We've talked about it several different times in these webinars at this point. As I had mentioned, it has that CenXL 135 PCS built into it, so it can AC couple. A really nice advantage of it being a 480Y configuration as opposed to 480 Delta. It's a major product improvement over our 233 currently. Helps remove the need for an isolation transformer when you're connecting it to loads. So it really just improves the flexibility and diversity of the piece of equipment to stabilize interfaces and to reduce the amount of supporting equipment that you need. These can be run in very high degrees of parallel. Part of the reason that this is a good advantage is that if you are doing that AC coupled configuration, you can run multiple arrays of these, four of them in parallel for a megawatt, and then connect those together to create a single array. And then those arrays can then be paralleled together to get over like 10, 15, 25 megawatts of power if we really need to. And then that has the ability to step up and really hit those grid voltage or transmission voltage requirements of 10 kilovolts, 35 kilo, all the way up to 35 kilovolts if you have enough juice across the board. So really capable system. It has a lot of flexibility. It's one of my favorite systems because it's a great AC coupled add-on for existing solar systems or diversity of use cases. You can run solar directly into it. If you're doing new install, you can run the DC fast charger directly out of it. You can run solar. You can do instantaneous changeover, so it's grid good for um, data center backup as well because has like a sub 20 millisecond changeover time. So really great product. A ton of flexibility in terms of use case. A lot of different ROI validation approaches and gives you a lot of flexibility depending on whatever your use case might be. It's a pretty concise or compact form factor. So it gives you a lot of uh, choices when it comes to charging or placing them with different places. The 261 is UL 1741 certified. UL 74 SB, I will clarify. We actually can look at the next slide here. We have our full parameters on here. The certification list is UL 1741 edition 3. So supplemental SB. Yes, it does look like we have the SB on it. This again, oh sorry, I'm answering that live. The answer is yes to that. Um, This is both of these products, the 261 as well as the EStand, will be fully certified and available by April 5th is our official launch date for these products, which I'm very, very excited about. It's just around the corner and is coming up very soon. To dig into these a little bit more, on the right side here, you can see all of the DC fast charger parameters. So this is where you're going to see our max power. I know it's small here, so I apologize, but our max power output of 400 kilowatts, as I had mentioned, and that's paired with a max current of 400 amps, and that's when we're at that high enough voltage of 1,000 amps. So that kind of math is pretty straightforward there in terms of how you get to that 400 kilowatt power output. It's a very efficient system, round trip efficiency of around 97%, and very stable, capable of using peak shaving as well as all whatever of your energy management systems that you want to use, all kind of integrate to form this production here and to get this much power out as needed. Capable of being installed as a floor stand, very easy and straightforward. Currently, I will say we are OCPP 1.6J. We're in the process of communicating with the team to move ourselves towards 2.0.1. That just gives you more flexibility in terms of different communications protocols that can be loaded on there. It allows the charger to be a little bit more flexible with different interfaces and different vehicles that come out in the years to come. Again, we're really trying to make sure that our equipment is future proofed. And if you buy something, it's going to be functional and ready to last the next 10, 15 years, 20 years, and still be relevant in the market with the right technologies. So the battery systems and control systems as a whole are capable of being either Wi-Fi connected, Ethernet. You can even put a SIM card in them, so you have full LTE connection to them, which is really nice, especially in those remote locations. Because a lot of the time, even if you have Wi-Fi on site, the batteries are pretty far outside of the range of the Wi-Fi, and we've seen that happen several times over, where it's you hook something up to the battery or to the Wi-Fi, it gets connected, there's like fluctuations in the signal, and it loses the signal, and it's just troublesome to have to keep getting it reconnected. So different factors to think about there. All I think are considered as we develop this EStand and really are trying to optimize it as a battery. The operational benefits as a whole, again, just to really refresh and cover the high level to zoom back out a little bit. We've kind of got really down into the weeds looking at the product, its specifications, but to zoom back out in terms of why add a BESS solution to your DC fast chargers, peak shaving alone is a tremendous requirement. You know, just taking off that 50 kilowatts of demand charge that can sneak up on you when you first drop a DC fast charger, that alone can be huge savings. Again, people are paying an additional $2,000, $5,000 a month just in those spikes in demand charges. So if you're paying $5,000 a month, something like this could pay back easily within your like less than 5 year ROI and a very, very significantly less than that. So really, really major benefits for the rate of return on those. Um, the load balancing. So if you have potentially unstable grid or unstable energy production, it is really nice to be able to minimize and stabilize the entire load over the course of a day. So you're not seeing big jumps and dips in your production requirements and your draws from the grid because you can trickle charge from the batteries or to the batteries and then rapid discharge out of them. So really quick way to improve the entire site economics and to improve system payback. There's just a lot of benefit to the approach that having better energy storage to support DC fast charging. Real quick, just a quick little reminder here. This is our XGen. This is another product that we've talked about in depth. And the reason I bring it up is because it is DC fast charger integrated. There is a charger connection to it. So you can use this as a portable DC fast charger. That's another fun component to consider here. Let's take a quick look at another question that came up. Are you able to control voltage and frequency with a 261 and EV charger? So the DC fast charger can control its voltage depending on to match the voltage requirement of the battery. That's going to be something that's done by the DC fast charger system. The AC coupled system cannot fluctuate its voltage output. It's just always going to output 480. Within its ability to output 480, there is some slight frequency modulation controls, maybe like plus or minus a hertz or half a hertz, which is really all you really need to do in order to create charge out versus charge in. Part of the reason we do that is for integration with some external controllers like DIFE controllers that are primarily drive energy direction based on frequency modulation. So just some considerations there. I will get you answers and we'll have answers next week at the summit regarding the wind lines, DC fast chargers' ability to modulate frequency in addition to voltage. I know it can adjust voltage to match what the car is requesting. And they've been in the game for a long time. And if any cars require specific frequency adjustment or frequency modulation, it's certainly capable of doing so. Sorry, I will need to remember to click the answer live question so you guys can see the question that I'm talking about. Didn't mean to just to ramble there. So, are we able to control the voltage and frequency with the 261 and EV charger? The answer on the EV charger side is yes for voltage and frequency, and 261 is always going to output at 480 AC. Well, once it runs through the PCS. We can use MPPT cabinets in order to fluctuate the voltage intake. So you can, like I said, directly DC to DC couple solar. So some cool flexibility and options there. If you have any applications, feel free to reach out. We're really happy to help co-design a lot of these systems. Oh, we got a nice survey coming up. We appreciate everybody's participation real quick here. Which dispenser configuration do you think is the most critical, and which one would you prefer? NACS, CCS1, or some other third party? It's always nice to collect some additional data while we're in here. I appreciate that.
I went ahead and added this poll because we are offering both. Just from my experience and being an EV driver myself, I prefer having NACS, knowing that all the current and future vehicles are adding NACS. But I know that a lot of vehicles and fleet stuff from the past already has CCS1. So if you don't mind giving us an answer here, we are going to have both options. The question is more about which would you prefer us to lead with, or just having both options. And this applies to both uh, the EStand as well as this XGen that we have on the screen. Thanks,
Yeah.
guys. But we can keep going, Russell. Thanks.
Yeah, yeah, absolutely. And I mean, with that, that kind of takes us to, I mean, we've talked about this product in other webinars. We have other webinars on it. Feel free to go visit our website and to review those. We'll host these again. We'll kind of continue to do product deep dives over the next several months, maybe like once a quarter per product. But we have a couple of fun use cases that we're looking at islanding coming up. So if you want to if you want to reach out to us, please feel free to do so. This is all of our contact information that we have here on the next slide here. And yeah, so you can reach out to us at the info at renonpower.com. You can reach out to us directly via the phone numbers that you see listed below. The great place to start is always just renonpower.com. It's going to have all the information you need. Like I said, or like Pablo said, we are a global company, but we are a standalone organization in North America. We just have strong partnerships globally. So I'm very excited for what the future holds. Our McKinney facility is going to be up and running here shortly, and very excited to be talking more about this at the EV Summit next week.
Just a reminder, Russell and I will both be in attendance next week at the EV Charging Summit in Expo, so definitely come by and check us out. We'll have the latest spec sheets for these products, as well as some other ones as well. So looking forward to seeing you all there. Definitely check us out on LinkedIn, social media, Facebook, Instagram, YouTube. We're posting on there multiple times a day, showing lots of case studies and use cases, as well as solutions for upcoming products. So definitely check us out, and we appreciate your time today. Uh, Russell, do you have any other things you want to follow up with?
No, I did see we did get a question on ballpark pricing for the EV charge station. As the product is coming out in April, we're still finalizing some final numbers as price of lithium changes. There's just a lot of factors at play here. So I really encourage you to reach out to our team and we'll be able to get you a ballpark quote probably in the next week or two here, rather than discussing it here.
Or you can come check us out. I think we should have pricing more clear next week.
Awesome. Yeah. Thank you.
All right. If there aren't any other questions, you can definitely reach out to Russell and myself. Individually, you can find Russell just at obviously on LinkedIn, but Russell at renon-usa.com
Yep.
or Pablo at renon-usa.com. We're looking forward to answering any questions and supporting with any upcoming projects. Like Russell had mentioned, this product will be certified in a little over a month, I think about a month at this point. But if you're looking at getting a test product lined up, or you have more questions on this, just definitely reach out to us and we'll get you situated and taken care of.
Awesome. Thanks so much, guys.
All right. I hope you guys have a nice rest of your day. Thanks for joining.